Welcome to GTV. Today I would like to demonstrate how to do a basic startup and operation of a Fuji Electric Frenic Multi-Series AC drive using the keypad. After verifying that the wiring is correct, I will apply power to the drive so that I can begin programming. First, I'll review the keypad. On the top is a 4-digit 7-segment LED monitor. It displays running status when in running mode, menus, functions, and data in programming mode, and alarm codes in alarm mode. On the left, below the display, is a program reset key, which switches the operation mode of the drive. Beneath this key is the function data key, which in running mode can display different information concerning the status of the drive. In programming mode, this key will display the function codes and sets the data. The rest of my operation keys are the up and down arrows and the run and stop key. The run and stop key are used to run and stop the motor. Through this setup, I will demonstrate in more detail how these buttons work. Next to the display are 3 LED indicators and a keypad control LED. The 3 LED indicators identify the unit of numeral displayed on the LED monitoring in running mode, such as in kilowatts, hertz, amps, load shaft speed, and line speed. For further information, refer to the Monitoring the Running Status section in the owner's manual. To switch the drive to programming mode, push the Program Reset key. While the drive is in programming mode, the LEDs of hertz and kilowatts should be illuminated. Now that I have reviewed the control panel, I will begin to program the drive. First, I check to make sure the 0-point FNC is on the display. If it isn't, I will push the arrow until the display reads 0-point FNC. I will push the function data key to access the function codes, where I will input my motor information. I can get the motor information from the nameplate that is typically attached to the motor. The F01 should be on the display here. This fundamental function sets the source that specifies the reference frequency. I will hit the function data key to change the data. Right now, the function code displays a 0. Using the function codes table in the instruction manual, I know that this 0 shows that the current source is the keypad. Since I will not change my parameter here, I will push the program reset key to go back a step. Now I'll push the arrow key up to the F02 to change the operation mode. This allows me to change the operation to the keypad or terminal operation. It also allows me to change the direction of the motor without the need of terminal input. I will hit the function data key to change the data. Right now, a 0 is displayed and the run command source is the keypad, but the motor direction is indicated by a terminal. If I go up 1, the mode of operation can be set to come from an external source. If I go up once more so that a 2 is displayed, the mode of operation is the keypad with the direction of the motor in forward rotation. For demonstration purposes, this is the desired function. I will hit the function data key and the word save will appear on the display. This shows that the data is saved in the memory inside the drive. I will push the function data key on F03 to change the maximum frequency. For demonstration purposes, I will use 60 Hz. If I wanted to change this, I can use the up and down arrows to change the maximum frequency accordingly. Once I have reached my desired frequency, I will push the function data key to save. The next function is F04, which is the base frequency. To change this, I will push the function data key. I will use the data found on my motor's nameplate to set the data to 60 Hz. I will push the function data key again to save. F05 should be on display. This function is where I will set my rated voltage. I will push the function data key and use the arrows to set the rated voltage to data found on the motor's nameplate. This number is 230 volts. I will then push the function data key to save. Next, I'll push function data on F06 to check my maximum output voltage. I prefer to keep this on my default setting of 230, right around the rated voltage. Since the setting is already at the optimal voltage, I will push the program reset key to go back to the menu. I'll push the arrow up key once more to show F07. F07 controls the acceleration time of the motor, as F08 controls the deceleration. The default should be 6 seconds and should only be changed should the application require doing so. Since I won't be changing any of the defaults, I will continue to scroll up with the arrow keys until I reach P02. This is the rated capacity, which can be found on the nameplate of the motor. This is indicated in kilowatts or horsepower depending on the motor. I will also need to change the drive settings in a little bit to let the drive know which unit we plugged in. This particular motor displays horsepower. I will push the function data key to change the data setting to match my nameplate data of 1 horsepower, and then push the function data key again to save. My next parameter is P03. This is where I can change the rated current measured in amps. I will push the function data key to change the data setting to match the nameplate data of 3 amps. I will then push the function data key to save. My next parameter is P04. This setting should be changed if you want auto-tuning. For this demo, I will skip auto-tuning and continue to arrow up to P99. This parameter here is directly related to the type of motor used. I will push the function data key to edit this field. 0 indicates that the drive is currently set up for a standard Fuji 8 series motor. The number 1 here displayed indicates the drive to be set for HP rated motors. The number 3 indicates a Fuji 6 series standard motor. For all other motors, number 4 should be selected. Once I have selected appropriate motor parameter, I will push the function data key to save. I should now have put in all the necessary parameters to start my motor. With everything saved, I can push the program reset key to go back to the 0-point FNC, and then once more to see 0.00 Hz blinking on the display. I can set a low reference frequency such as 10 Hz using the arrow keys. I will then push the run key for the motor to turn in the forward direction. To stop the motor, I will push the stop key here. The Multi also has additional modules sold separately to increase the functionality and versatility of the drive. For example, I have here a multi-protocol wireless Ethernet communications interface card. To install, I can remove the keypad from the front cover of the drive and then remove the front panel. The bottom wire here can be inserted into the port on the drive, and the wire can lay in the opening on the left side. I can then replace the front panel and insert the module on top of the front of the drive. The keypad can then be inserted on the top of the new interface. The Fuji Electric Frenic Multi Series AC drive, along with thousands of other products and services, are available at galco.com.